We're going to take a look here at solving basic equations. Before we do, let's take a look at an equation and understand what each of the components of the equation would be. Alright, so this first part, this 4 that is on the x. The 4 that is on the x is called the coefficient. Alright, so that is always the constant that is being multiplied by the variable. Alright, the second part of our equation here is the x. The x is the variable. The next part is the 6 and the 14. Each of those are constants. And the last part of the equation is what actually defines the equation, and it's this equal sign. That equal sign means that the whole left side of the equation must always be equal to the whole right side of the equation. So when I'm solving an equation, I like to think of the two sides of the equation as a scale, where the two sides of the scale must always be balanced. Okay, so for these two sides to be equal, on the left side of the scale, we would end up with 4x plus 6. On the right side of the scale, we end up with 14. What we want to do is solve for x, meaning we want to get this x right here all by itself. But we need to keep our scale balanced at all times, meaning whatever we do to one side of the scale, in order to keep it balanced, we have to do to the other side of the scale. So the first thing you want to do is deal with this plus 6. So on our scale, here we want to subtract 6. But if we're just to subtract 6 on the left side, our scale wouldn't be balanced anymore. So we want to balance the scale, so we need to subtract 6 on the right side as well. So by subtracting 6, we end up with 4x on this side of the scale and 8 on this side of the scale. Alright, now to keep in mind we need to balance the scale. The last thing we need to do is we have this constant or the coefficient on x, and so we need to just divide both sides by 4. Okay, so if I divide the left side by 4, I end up with x. And then if I go 8 divided by 4, we have 2. So our scales, or in other words our equations, are balanced. So we have our solution of x all by itself. It's x equals 2. Alright, let's take a look at this equation. Now it's in a little bit more complex form. So when you're going to balance both sides of the equation, you can do something to one side of the equation. For example, I could distribute this 6 through, and that doesn't change the value of the equation. So it is okay to distribute through and simplify that way. So if we take a look here, I want to distribute that 6 through, so that would be 18x minus 6. And then I also want to distribute that 4 through on the other side, so that would be 20x plus 4. Alright, now what we have here is a variable on both sides of the equation, but the idea still works the same. So if I want to maybe bring this 18x, get rid of that 18x, then I would have to get rid of it over on this side, and it rebalances out my equation. So what we end up with on this side is negative 6x, and what we have on this side is 2x plus 4. All right, so I'm going to then, I want to get rid of this 4 by subtracting 4 there, but if I to balance out the equation, I need to subtract the 4 over here. So what I end up with is negative 10 and 2x. So then we just divide both sides by 2, and we get negative 5 on one side and x on the other. So our final answer then is x equals negative 5. Now normally the idea is whatever you do on one side of the equation, you have to do to the other. But that does not include simplifying the sides of the equation that need simplifying first. All right, let's take a look at a special case of type of equation. So I'm not going to actually draw out the scale every time. So let's just assume that we do have a scale there. And we will try to solve this with the same idea in mind. So the first thing I want to do is simplify this side of the equation. So I'm going to distribute the 7x through. And combine like terms, we get 4x minus 21. And we did not change this left side of the equation. Alright, so then we need to combine the x's, so I'm just going to subtract the 4x over on that side to that side. And they do go away. 4x minus 4x is 0. So we end up with 3 equals negative 21. Now if you think of this as a scale, does 3 balance with negative 21? It does not. So 3 cannot equal negative 21. So since these are unbalanced, what we do when all the x variables cancel out, but they don't equal the same thing on both sides, we have no solution. Now likewise, and I won't do another problem, but just so that you know, if you were to have gone through this whole problem and you ended up with, say, 3 equals 3, then the solution is all real numbers. Everything you can put in for x would work because 3 does always equal 3. So that is what can happen. You can have one solution for x on these linear equations. You can have no solution for x, or you can actually have infinite solutions, or that can be said as all real numbers are the solution.